Another revision stream. Today we are revising what I would consider the easiest three topics. Okay, well, you know what we'll do before we get into any of this. I'm gonna make a tier list, okay? Because hopefully this will help you guys. If you guys are on a similar wavelength to me, you will agree with all of these rankings, okay? We're gonna rank it based on how confident we are with everything. So, S tier, A tier, B, and then C. Okay, so C is gonna be stuff that we rarely struggle with. S is gonna be things that are incredibly easy. So we'll quickly go through this, just so you guys can hopefully be on the same wavelength. Right, carbohydrates, I would consider easy as hell, okay? Definitions like isomers, monomers, polymers, glycosidic bonds, even the tests, the starch test, the Benedict's test, even things for non-reducing sugars. I would consider myself insanely confident with carbohydrates. I think it's a very easy topic, and I think they can't ask you too much about it in an exam, so it's a good one to keep well informed on. Lipids, I would say, are honestly... There's a couple definitions that I really struggle with lipids, like when they ask you why does it form a bilayer, why do phospholipids form a bilayer, I find that difficult to put into words, even though I know why. Also, I forgot to check the polarity of phospholipids. They're polar molecules, but what bit is positive, what bit is negative? The heads are polar. So that's a positive charge, and they have the hydrophilic bonds. Okay, good to know. So I would put lipids, further down. I would put them at, maybe a mid-A tier. I know them quite well, but not well enough that I could waffle about them for long. Also, one thing I forgot to mention about lipids, they affect the fluidity of cell membranes, okay? So, if we have our phospholipid bilayer here, which I'm going to draw incredibly crudely because I do not do A-level art and I wouldn't dream of doing that, Jesus Christ. Okay, you have to remember phospholipids, you have the phosphate group, the actual phosphate... Hold on, they definitely do have... Yes, hold on. Am I being silly here? Hold on. Have I been drawing phospholipids wrong this whole time? No, just the diagrams are weird. Okay. So actually, in reality, that's what a phospholipid looks like. But we tend to draw them just like this. That's interesting to know. That's cool. Anyways, to get to the point, one of these is saturated, one of these is unsaturated. This is going to kink to the side because it's unsaturated. And what that means is that the more unsaturated fatty acids there are, the more fluid this membrane will be, because instead of the chains being fixed, they're going to be bent. Just a little thing to keep in mind, because there has been a 6 marker where a good chunk of it was you having to refer to the fluidity of membranes, and you would have dropped 1 or 2 marks for that, so good thing to keep in mind. Very good thing to keep in mind. Okay, so lipids. Proteins, I would say, are a bit higher than lipids. They're a topic that I can waffle about quite well, but I tend to miss a couple obvious points now and again, especially when we talk about enzymes. Enzymes I would put right here. I would put right in between S and A tier. Enzymes are incredibly easy if you know all of the keywords, but you can still get slipped up on them because you don't use right terminology. For example, even saying something like the active site is occupied could be the difference between 1 mark or no mark, instead of saying, something else. Now, the other topics, I think, other topics. ATP, I would put here. Water and ions, I would honestly put ions here. There's not much you need to know. And water, I would actually rank the lowest. I remember water the worst. So on this tier list, I would say ions, carbohydrates, enzymes. Revise the exam technique for these, not the knowledge. Because the knowledge is easy as hell to remember. What isn't easy to remember from these 3 topics is all of the ways they can trick you in an exam. With these topics, revise the content, focus less on the exam technique. That's what my advice would be if you're struggling with the biological molecules topic. Anyways, we've been waffling for approximately 7 minutes, so let's start talking about adenosine triphosphate. It is going to be... Hold on. Adenine... Is it just this? No, it's ribose. Almost forgot. Okay, the structure of adenosine triphosphate. The thing I always reference is a very good exam question where they ask you to compare the difference, the structural difference between ATP and DNA. Because it's an exam question that people get wrong all the time. But actually, the structures in both of these are incredibly similar, okay? We're not doing DNA today, for obvious reasons. I'm tired, but structure of DNA, you have a phosphate group. This one has 3. Both have a nitrogenous base. In ATP, it's always adenine. In DNA, it could be adenine, thymine, cytosine, or guanine. This is ribose. This is deoxyribose. Remember, DNA stands for deoxyribose nucleic acid. D, that stands for deoxyribose. That's what this is. That is ribose, which is a pentose sugar, because it's a pentagon. Okay, let's talk about the properties of ATP. This should only take a minute max, if we're good. Okay, the idea with ATP and the ATP cycle is that these are high energy bonds. Okay? When these bonds are broken, energy is released. There are some properties that we need to know. Number 1, the energy is not all released at once. A very common misconception, but not all the energy released by this bond is released at once. So the energy can be released in short bursts. I will look at a mark scheme to see exactly how you would word this, but it's something along those lines. Short bursts of energy. Number 2, they can easily be recycled or regenerated. Because remember, this then becomes ADP, which is the exact same structure, but with 1 inorganic phosphate missing. That's what adenosine diphosphate is. Another couple properties, just some really basic ones. I'm pretty sure it's soluble, and it can't exist. It can't move from cell to cell. So it cannot move from cell to cell. It has to remain in one cell. I'm trying to remember what other properties there are, because I think this is most of them. There's probably 1 or 2 really generic ones that I've missed. like something like, oh, it's a reliable source of energy. Like, piss off, AQA. We know it's a reliable source of energy. We know how reliable it is. I promise you. Let's look at a mind map here. This should help. Yeah. The formation... Okay, two things I always need to drill into my head, as well as you guys, is condensation and hydrolysis. Always mention the fact that ATP becomes ADP because of a hydrolysis reaction, and vice versa. ADP becomes ATP because of a condensation reaction. Yeah, it's useful in metabolic processes. Oh, and the final property, the inorganic phosphate can be used to phosphorylize other substances, making them more reactive. We see this in glycolysis, where our glucose becomes phosphorylated glucose because of ATP breaking down into ADP via hydrolysis, obviously. And then this allows it to split into the triose phosphate and then pyruvate molecules. So, I think that's every property. I'm going to go check some mark schemes real quick. We don't need to do the exam questions. I've already done them. Okay, here. Releases relatively small amount of energy at a time. So what that means is that, let's say we release like a shit ton of energy at once. That's a lot of heat, a lot of kinetic energy, thermal death. So the idea there is that it releases a small amount of energy at a time. Second bit is it's instantaneous. The energy is readily available. That word right there, readily available. The energy is readily available. It is instantaneous access. So two properties right there. The energy released from ATP is readily available. Not all of it is released at once. It releases it in small amounts. Inorganic phosphate phosphorylizes other molecules. It can be rapidly resynthesized. So that idea of rapid regeneration. And it is not lost from cells, so it cannot leave cells, as I've said. The two properties of ATP, as we've said, provide energy for metabolic reactions. You can't say produce energy, you have to say provide, or, you could say something along the likes of that. To add phosphate to other substances to make them more reactive. The idea that more ATP, more energy is because more ATP hydrolysis. There is a really devious question where it asks you, how is ATP formed? A lot of people waffle about, it travels down the channel protein, hydrogen ions. Shut up, okay? This is such an evil question. All you need to say are the three compounds of it. So the three components of it. So off the top of my head, that's obviously going to be adenine, the three inorganic phosphates, and the ribose. Then you just need to say that it's a condensation reaction which bonds them all together via ATP synthase. So that right there is a mark that I think like 20% of people got worldwide, or nationwide, because most people waffled about, hydrogen ions and its respiration. That's not what you do. All you have to do is list the components. Why are they bonded together? What allows it to bond? You get the idea. Condensation. Right, let's move on to ions, because there are only like 3 that we need to know. I think there's more when we move on to some other topics, so I'll be sure to update this video. eventually, but for right now, you need to know hydrogen, iron, potassium, and what is the other one? Sodium? Or is there another one? Okay, let's just go off what I know, and we'll come back to these. Okay, hydrogen affects the pH. Pretty sure it's more hydrogen means more acidic conditions. So that right there is what hydrogen does. It increases the acidity depending on how much. Or in other words, it regulates the pH, okay? The more hydrogen, the more acidic. Iron is an important compound in hemoglobin, which I always spell wrong on stream. I wrote hemoglobin. Hemoglobin. Other words, it's a quaternary protein. It looks a little bit, if we assume each of these is a secondary protein, tertiary protein structure, all bonded together, that's hemoglobin. In each of these, I think it has, I think it's 2 iron ions per heme group, I'm pretty sure. In other words, each one of these can absorb 2 oxygen atoms, or 1 oxygen molecule, I believe. Potassium and sodium are both in the same. It's this idea of the NAK pump. The sodium-potassium pump. This idea that when sodium travels through, it goes through a conformational shift when sodium travels through, which causes this structure to become different, allowing for that to enter. Also, an important part of co-transport when the sodium is transported out. So let me just remember where I put it. There we go. Inorganic ions. Okay. Yeah. Oh, and the last one was phosphate ions, which obviously a component of ATP and DNA. Iron ions, hemoglobin. Hydrogen ions, pH. Sodium ions, co-transport. The idea, by the way, with when it's called inorganic ions, that literally just means it doesn't have carbon. Idea of ions is that they are charged molecules. Cations are positive, anions are negative. Cool, right. Water. Final bit, water is a very important metabolite. I don't know if I'm saying that right, but it's used in metabolic reactions, like condensation, like hydrolysis. Idea is that water acts as a temperature buffer because it has a high specific heat capacity. So again, it acts as a buffer. That's why things like a layer of ice, the water under it won't be as cold because it acts as a temperature buffer. A lot of energy is required to heat it up. Cohesion and surface tension. This is the idea that we have OH. It's this idea that when water molecules bond to each other, it's these very weak bonds. I'm wondering, the word hydrostatic tension comes to mind. Don't recall what context that's used in, but it's this idea that these bonds are actually weak because oxygen is electronegative, these are positive. So it's this idea that these bonds are weak, and as a result, it provides it with a strong cohesion tension. It's a very cohesive substance, water, and it's this idea as well with water that again, acts as a temperature buffer because of its high heat capacity, strong cohesion tension because of the interactions between the water molecules, the bonds. Water molecules stick together. Evaporation, it has a cooling effect when evaporating off the skin. We haven't learnt that, so that's an interesting one to know. Maybe literally you just need to write in your books for that one, evaporation. Evaporation equals cool. Maybe that'll help you one day. Metabolic reactions, condensation, hydrolysis. Last thing we need to know, it's a solvent. So pretty sure a solvent allows other substances to be dissolved in it. So other substances can be dissolved. Right, that is everything we need to do today. I am sorry, I'm going to have to end the stream early because I am knackered. That is about everything I can think of though. We have basically rushed through 3 topics there that are quite easy. Water, the only thing I would say is keep on top of the definitions. High specific heat capacity, high latent heat of evaporation. It's what was it? Solvent, yeah. And high cohesion tension. You get those right, you get the exam right. If you get asked, okay, there was an essay question which asked about water. If you don't know what to say, just genuinely think about it for a second. Water is used in so much, it's unreal. You could talk about the xylem, the phloem, transpiration, translocation. You could waffle about condensation and hydrolysis. You could waffle about literally anything. You could waffle about how species require it. You could talk about the tips of water in the tracheoles. There is so much to write about in regard to water. So, good luck.